everyone. So my name is Nishant Gaurav and I lead R&D team in NPCI. And I am a SME, subject matter expert on EMV and tokenization. I was associated with NPCI from last 7 years. And currently I'm taking care of mobile payment application security. So coming back to our topic, tokenization. So there's a lot of buzz in the market regarding the tokenization. And there is, there is a compliance from RBI for all the e-com player, either it's a merchant, PG, PA, to comply with the tokenization guideline. And I think deadline for the tokenization compliance is 30th of September. Initially, it was last year, December 2021, and RBI is extended to 2022 September. So we are, I think, reaching with the deadline. So before we get into the RBI guideline and what is all this card on file tokenization, so I prepared my slide that what is tokenization, why it is, you can say, important, and what are the use cases which are there in the market related to same. So first, tokenization is something, a concept. I think it was evolved in the market in the year 2001. One of the company has implemented that in the 2001 with a company classmate.com to secure their payment data. So it's not something, you can say, a new concept. It was implemented 20 years ago. And after that, it was evolving and gradually everyone were implementing this basically in the payment field. So tokenization, don't, you can say, restrict this tokenization solution with the payment card only. You can do tokenization in the Aadhaar also, or DL, any information which you think you are sharing in the you can say third-party website, third-party application, and that is secure. There you can implement this concept. So of course, in the back end of this concept, there is an encryption and decryption is there. Of course, the cryptography methods are there, how the data will be secured. And to do that, even EMV code, there's a international standard body who you can say manage the you can say card application and terminal EMV code application. They also have a guideline or framework regarding this. You can create your token system and get your system certified with the EMV code. But for that, you need to follow the guideline or you can say framework which EMV code has written. So that is also there. And above that, of course, PCI is also there because we are talking about the data security here and the data which get used for the payment transaction. Basically, when we talk about the Aadhaar tokenization, of course, how your Aadhaar number will be secured. And for that also, UDI has, you can say, hosted their vault at their premises to store the, you can say, secure the Aadhaar data. And I think many of the issuer has also implemented, there is a guideline from the UDI to secure the Aadhaar data in the token vault. So tokenization in the card world, because today we are going to talk about the card tokenization. So tokenization in the card world is nothing to replace your card number with the equivalent number, which will look same, but it will not be your actual card number. It will be different than your card number. Why tokenization? You can say you can use any encryption technology to encrypt your card number, but it's not that simple that you are just encrypting or you can say encrypting your card data. Other than that, there are a lot of, you can say, properties comes or attributes comes with that tokenization. You can set the expiry, you can do so many things. I will talk in next slide. De-tokenization is another world where when you are creating a token, then to get a real card number, when you are getting the real card number, that concept is called de-tokenization. So token means you are converting from PAN to a equivalent card number, and de-token is something when you are reconverting your card number from your token number. Of course, data security and all, you all are aware about that. So these are the, you can say, keywords or attributes which are famous, which are very, you can say, famous in the techie world. First is how the tokenization is there in the card environment. One, you can divide this tokenization concept in the card. One is token on file, another is card on file. So there are two use cases are there in market, token on file and card on file. Token on file is something when you are using your card number to do a e-com transaction. So there, when you are generating a token, that concept normally calls a token card on file. So card on file, that comes when you are doing it for the e-com transaction. And token on device is another use case where you are again generating a token, but that token remains on the mobile. So the RBI guideline which is there in the market, that is for the card on file, not for the token on device. So there are two use cases. Normally token on device is getting used by those payment players who are directly giving you a payment app like a Google Pay or GeoPay. So there, what the concept is, you can provision your card, or you can say create a token of your card number, and then after doing that, you can use your mobile phone to do a tap and pay transaction. It is the same like a card present transaction, but the only form factor is getting changed. Even if someone is doing a transaction using a wearables, that is also same like a token on device. So token on device means token is present on the device which you are using. Token on file means token is somewhere there in the web, not on the device. So like if you are doing a transaction in the Myntra, Flipkart, so those all are the classic example of token on file. Payment token, whenever you are creating a token using your card number, so the token which you get, that we call it as a payment token. And there is another word, token cryptogram. So now, currently how the e-com transaction takes place, you have a card number saved at any e-com website or merchant site. There you just enter the CVV and then you enter the OTP and the transaction goes away. Here, there is a concept that a real-time number, that's a unique number, can be generated. That number is called a cryptogram normally in the techie world. Also, some of the network uses that term as a dynamic CVV. So basically, it's you can say a unique number that will get generated every time when you are doing a transaction, just to secure your transaction and to ensure whosoever is initiating the transaction that is having capability to generate that particular unique number, and that number can be verified later on by the scheme or by the issuer. Identification and verification, it's ID and V, it's again a term which everyone uses. That's whosoever is registering their card on the merchant side, that to do that, you need to do a second factor authentication. That's called identity and verification. So there are three ways to do that currently. One, you can verify your customer using the OTP, which you have sent on the, you can say, SMS. Second, you can verify your customer by sending that OTP on the email. And third one is that you can also verify the consumer by giving a call back using the customer care. So let's say I'm at a location where my network is not there, but still I want to do that. So there the customer care will call you and you can re-verify that. So these are the three methods normally followed by all the schemes. In the market, I think you can say as OTP over the SMS is in the practice. Everyone follows that. But additional to that, you can do other two also. There's no restriction. All the network supports all these three methods. When I'm talking about network, I mean to say RuPay, Visa, and Mastercard, because they are only eligible to maintain this token or manage this token life cycle. Then token key attributes, others are, like I was telling, it's not as simple like just an encryption and decryption of a PAN. More than that, when you are creating a token, you can set an expiry of the token. Till what time the token will be valid, either for a year, month, day, or for 10 years, whatever. Normally, in the practice, token expiry is set as a card expiry, but you can set it as a less than card expiry also. I think that's a better idea because if the token is getting changed time to time, that will be better. Because if you're not replacing the token, then again there is a risk. What's the purpose of creating the token? And it's the same like having a card number on the merchant app. Second is token replenishment. So again, this is a replenishment is a term where you can update or you can change the value time to time. So let's say you have a certain expiry of the token for a 3 years or maybe 1 year. And after that, the token need to be updated. Means a new token will be generated. And again, it will be, you can say, stored at the merchant site or TR, wherever you want, you are storing that. That I will tell you later on that how the storing is being done. So to replace a previous token with the new token, that method is called replenishment. So whenever you heard a term replenishment, means you are replacing something. And also in the tokenization, there is a concept of how the token is getting generated. So there's a key associated with the token. And that key is also getting used to generate a unique number which I was talking that takes place in the transaction. So that key is also can be, you can say, replaced time to time. You can set an expiry of that key also. So you can see there are a lot of flexibility there in the concept. You can change the token. You can change the key associated with the token. You can set an expiry. So all this flexibility which that tokenization provides you. That's why everyone has opted for this. Then LUK is a limited usage key. So the key which is going to use to generate a token is called as a LUK, limited usage key. So let's say you have a device and you're storing a token on that. Along with the token, you can also store keys which will use to generate the token. And you can set an expiry of the key that every time the key will get replaced. So that also reduces the fraud, you can say any of kind of fraud risk, because you are replacing the key as well as the token. So if fraudster is able to retrieve the token, you are changing the token and you are changing the key also. So at any cost of time, it is quite impossible to, you can say, crack that method. Then there is a token reference number. So along with the token PAN, which is now your PAN, which will be used to do a payment transaction, there is another number which is associated with that, is called a token reference number. That reference tells, yes, I am the reference of that particular token. So how it happens, let's say there's a small merchant, any of the small merchant. So every merchant doesn't have a capability to manage the token at their end. And also you can rely on the system that every merchant follow those hygiene to manage the token at their end. So then how the transaction will happen at that merchant side. Let's say you have stored your card number on any of the ABC merchant, and now the merchant is having the token number. So again, the risk lies at the merchant reliability, or how the merchant, how much technically sound that merchant system is. So then there is another concept. You can generate a token reference number that will never be used for a transaction. And that merchant will store the reference number. Whenever merchant wants to do a transaction, he will first knock the door of those who is having a token, and he will get a token, and the transaction will be processed. So token reference number is reference to the token, but it is not a real number. It's not but it will never be used for any of the transaction. Then PAR is another concept, payment account, PAN account reference. So let's say I have a card and I have generated, let's say, 10 tokens of that card. Although those tokens will look different, but as a issuer or as a, let's say, TR, if you want to know, does all those tokens which I am generating come and link to the same card number or not? This is only possible when you are storing a card number also. Let's say I am a merchant and my card is with me and my card is with my friend. Both are registered on that particular merchant with a different user ID. So now on that merchant, same card has been registered twice and the two different token has got generated. Now the merchant pain is that how merchant will know whether that those two token belongs to the same card number or not. Because based on that, merchant will run their, you can say, any benefit programs that if the first time user, first time you will use a SDFC bank credit card, then you will get such and such benefit. So how that will happen? So for that, there's a reference of par concept is there in the market for the token. Par is same like a how issuer currently, I hope you guys understand issuer, bin and all those things. So par is something same like how issuer is managing the bin. Like for a bin, if a scheme need to distribute a bin to any bank, scheme need to go to ISO and BIS and EMBCO, and then they need to procure a bin. So in a similar way, for getting a par also, you need to get a range from the ISO. So that par will be linked with that particular card number. So by using that par, as a merchant, you will know that this particular par, this par is same across all the token, but the par will never be used for a transaction. So how it happens? This is your real card number, then par, and then multiple tokens are there. So you have a par, so you know, okay, all those tokens belongs to the same card number, but that par is not going to be used for a transaction. It's only for the reference for the merchant. Then token domain specify where the token, so you can also set a rule against the token that where the token will be used, whether this particular token will be used for an e-com transaction, whether it will be used for any, you can say, card present like a POS transaction, ATM or whatever. So you can set that domain rule also against that particular token. So these are the stakeholders involved in tokenization. So I think this flow shows that customer buys something on you can say any of the website or merchant app, customer enter the card number, and then card gets securely saved at some location which is called a token vault. So those who request a token, let's say I am a merchant, I am requesting, and I am a merchant, and at my merchant, any customer logins and enters their card number. So I am requesting a token from a scheme. Let's say NPCI is the scheme. I am requesting a token from that. So that particular requester becomes a token requester. So that entity who is requesting a token on behalf of a consumer, that entity is called a token requester. Second, there is a stakeholder called a token service provider. Those who is providing the token services to all the merchant. So that entity can only be a scheme. So Mastercard, Visa, and RuPay. That can only be a token service provider. Other than that, issuer can also be a TSP. That is something, a guideline given by RBI. So though, like if a SBI is an issuer, so all the SBI card can be managed by SBI as a TSP also. Other than that, scheme can also act like a TSP because scheme issues the card with the different issuers. So TSP can only be a scheme or issuer, but not other than that. None of the merchant, none of the PG, none of the PA can be a token requester. And what is a token requester? Token requester is an entity who manages the token life cycle. Those who store the token at their end, those who host the token vault at their end, those who maintain all the consumer card credential and the token. So the entire facility of giving the tokenization solution is managed by the TSP. So RuPay, Visa, Mastercard is a TSP. Any of the PG, let's say Razorpay, PayU, those are the TR, and then merchant is Flipkart, Amazon, whatever. That merchant can also be a TR. There are guidelines from the different scheme that's who can be a TR or who cannot. Because if you start giving a TR license to everyone, then it will be difficult to, you can say, manage that, what are the hygiene they are maintaining at their end. So that's why there is a technical eligibility criteria given by a scheme that who can be a TR, who cannot be a TR. So normally big merchant applies for a TR license from a scheme, and small merchant relies on the PA and PG to be a TR. So Razorpay, PayU and all this entity act like a TR also, and they are a PG license from RBI too. And the merchant who are connected with those, all the small merchants, they are acting like a merchant. So they are not storing any token number, they are just storing a reference number. Because using that reference number, they are just knocking the TR door to give a token. And then TR is you can say, connected with the TSP to provide the token and maintain the token life cycle. So token life cycle means maintaining the, you can say, token credential, generating the token whenever the token is getting expired, updating the token, a replenishment of the token and the associated key with the TR. So this is the job of a normal TR. Now, token on device. So those terms or the discussion which I was having with you, that is with respect to card on file tokenization. So there is also concept of token on device. Token on device is something you have a, let's say in India, I think Samsung Pay has launched this and Google Pay has also launched this. Jio is doing some pilot on this. This is also not a very new concept. This is also an old concept, very famous in Singapore. Everyone uses that. But the challenge of this, this particular solution is that you need to have a NFC enabled phone. So this is one a drawback, or you can say a limitation. Because why you need that? Because you are having a card credential in the device, and now when you are doing a transaction on a POS or ATM, then how will you establish the connection? For that, the device need to be a NFC enabled device. For using a Bluetooth also it can be done, but none of, I think, technology provider or scheme prefers that method, because that takes a lot of battery power. So that's why no one prefers that. So the first thing is that for token on device, you need to have an NFC enabled phone. How it works, I will get into detail how this token on device implemented in the market. So how it works, you have a Google Pay application at your end. You open that and it will ask, registered your card. You entered your card number, expiry, CVV. They will do your verification using all this IDNV method, which I have explained to you, SMS, OTP, or customer care calling. Once it is done, your card will be registered on the Google Pay. Now it is not it's just a number that has got registered. In that particular payment application, whatever the you can say application which was there on your card, that is also present. So now your phone, after doing that, your phone becomes like your physical card. So all those EMV transactions which you are currently processing by dipping the card or tapping the card, so that exactly the same method will be applied for the transaction which will be enabled from the device also. So it will be an EMV transaction initiated from the device. Of course, it will be a contactless because there is no dipping inside. So how the transaction is happening, that is with the NFC. After registering your card, the card gets personalized on your device. And after the personalization, as the device is a non-secure zone, that's why you need a tokenization there. Because if you're not replacing the card number with the token, then again your data can be compromised. You can connect your Android on your mobile, on your laptop, and then you can go through all those data. So that's why the card, it is important to tokenize the card before you personalize in the mobile. So when someone says that I will tap my phone for doing a transaction, then it's a token on device, and it is exactly on the same line how your EMV contactless card works. So all the guidelines with respect to EMV contactless card, 5,000 and all, that applies here also. So, and for the issuer, because the transaction is getting initiated by the device, so by the device number mapping and all, issuer will able to know you are doing a transaction using your device, not using your physical card. Second, I think what I was talking here about, that you are, of course, you are registering your card on the device and you are creating a token to secure your card number. But still, all those data which is there on the mobile is not secure because it's not a dedicated hardware. When you are having a card, you are having a personalized card, it's a dedicated hardware. After the personalization, the card has got logged. You cannot open the card and do anything. There's no way. Of course, there's a reader by which you can go through the card application. But all those will be static data. But when you are registering your card on the mobile, in case of token on device, then the entire SDK, the entire application can be, you can say, copied by anyone in the token on device. So then how it will happen? For that, there is a mechanism in the market which called white box cryptography. That term is very famous. Those who implement token on device, they follows the white box cryptography to secure your application or data which are associated with the card. Because it's not only a card number, expiry, CVV, entire things will get personalized. So that is getting secured by white box cryptography. But the problem with WBC is that, one, it is very complicated, very complicated. You will not find anyone in India, hardly, who can work on WBC and give you a something application on that. And if someone will be able to do that, then your app size will get increased. Of course, there are methods in the market, or there are company in India, MNC, who works on that, who have expertise on that, but it's a very complicated subject. So again, if you're not implementing WBC, then there's a chance that fraudster can copy your data. There's a chance. Because as a technology provider, it's your job to secure the consumer data. You cannot rely on boss kuch nahi hoga. You cannot say that. Na? The technology which you are giving, you need to be very foolproof, or you need to be very sure that it cannot be tampered by anyone. If it's got tampered, then again you need to work on advanced technology. That is something how cryptography works now. Previously DES tha, second DES aaya, triple DES aaya, RSA hai. Now everyone is working on ECS and all. Because koi crack karta hai, then someone comes with another version. So that is how the technology evolves. So for that, there's another method. Just a second. So for that, there is another method called a secure element. So token on device can be divided into two, you can say, usage or implementation. One is SC, host card emulation, that is based on white box cryptography. And second one is secure element. What is the secure element? Secure element is something creating your secure area on a particular hardware. So let's say this is a room. Abhi, in this room, I have kept my laptop here. Anyone can access that. Of course, I can create a logical boundary and all. But if I create a special room for keeping my laptop, and I will lock with my keys and all, then no one can access. I'm sure no one can access. So that's in a hardware, creating a separate space for your application is secure element. So how it can be done? There are 2-3 ways to do that SE. One, you can have an embedded SE, where whenever a mobile manufacturer is manufacturing their phone, on their, you can say, motherboard itself, they can put a secure element. That's an additional chip for you. And in that chip, you can personalize your own application. So of course, most of the OEM, that's a mobile manufacturer, put additional hardware, and they go to the market and say every schemes, you can put your application in that particular secure area. So that's creating a dedicated hardware on a particular device is a secure element. So one is embedded secure element. That's creating a dedicated hardware on the mobile device. Another is UICC, by creating a dedicated hardware on the SIM also. Because everyone has a phone. Now, if you want to do a payment transaction, you can create a dedicated hardware on the SIM also. That also you can do. So that telecom provider, that's a Vodafone, Idea, along with their tech partner like IDEMIA, GND, all these all are, I think, number one SIM card manufacturer in the world. I think GND is something who has created SIM card first time. So they are the, you can say, that. Huh. Oh, sorry. Sorry, I was speaking continuously. So, Secure element, I was telling that. So second is UICC. You can create a secure area on a SIM also, and the third one is the you can also create a secure element on the micro SD card. Like you put a micro SD card on the mobile phone. There also you can create a secure element. Apple Pay, by the way, works on that secure element. So now all the Apple Pay that on all the Apple device, they have a dedicated secure hardware, and there they put their Apple Pay application. Google Pay works on that SC model. Samsung Pay also works on that SC model. Jio works on that SC model. This one. How this transaction works? So once you have you registered your card on the mobile, then now your mobile will act like your physical card. You can tap the mobile on the device and the transaction. So this is basically used for a card present transaction, basically. By using that, you can also perform an online transaction. Like if you go to a Flipkart, Myntra, there they will show you an option, pay by Google Pay. Currently, when you hit that option, you will get an option, pay by UPI ID and all. So if you have registered your card on the Google Pay, then there you can pay by your card number also. So additional to that UPI, you can pay by that. And that transaction is called an in-app transaction. So that's another term which are famous in the market. Card, and coming to the card. So we talked about the token on device, how the solutions are there, what are the use cases which are there in the market. Now coming to the card on file tokenization. Card on file tokenization is limited to a card not present transaction only. Wherever you're doing an e-com transaction, that card on file tokenization guideline, card on file, all those document applies here. So RBI has a guideline on that I've talked about, that they have previously they have given a deadline for last year. Now they've extended to 30th September. So what this guideline is that all the cards which are getting stored on the any of the merchant sites, that can none of the merchant, none of the TR can store the clear card number at their end. It has to be tokenized. One, how much they can store? There is a they can because once you are selecting your card, it is important that you need to match that which card number I'm going to use. So for that, RBI is allowed to store a first 4-digit card number on their merchant site. So by seeing the first 4 number and the card image, consumer can relate to the card and then do the transaction. But whatever you are seeing, that is the only 4 digit is stored at the merchant site. The rest of the card number is not stored at their end. That is being stored at the token requester site and then TSP. So TR can store token number and merchant is allowed to store token reference number. Why it is there? Because once a TSP has generated a token and he has given the token to any of the merchant, so that it is very important that if the merchant is not a TR, means the merchant system is not, you can say, technical compatible with the guidelines set by the scheme or TSP, then the merchant is not allowed to store a token number at their end, because that token number can also get copied by fraudster. So that's why how the flows happens. The TR merchant knocks the TR door to generate a token, and the TR is connected with the TSP, and TSP gives back the token number to the TR along with the token reference number. And what TR does? TR provides the token reference number to the merchant. So now merchant has only the token reference number and other parameters like a par and then token expiry and all those things. By using that merchant can relate that which are the token are registered at my end. Token reference number is unique as per each token and par is unique as per each card. So that is something I have explained to you, that whenever you are generating a token, your token reference number will get changed, but the par will never get changed. Token expiry can be set same as card expiry, maximum. You can set a lesser than card expiry also. Payment token has a various life cycle, like once you have created a token or created a token and registered a card on the merchant site, then it is important that, let's say you have lost your card. Then the token which are there at the merchant site, that token need to be deleted. How it will happen? Let's say I've lost my card, what I'll do? I will give a phone call to my bank, or maybe I will go into the net banking, and then I will place a request that please reactivate my card. And then what that issuer will do, issuer will give an instruction or pass this instruction to the TSP that please, these are the card detail, please block this card. What TSP will do, TSP will pass on this message to the TR that these are the detail, I am blocking this card. So no more, whenever you will now try the transaction using the token, that token is not valid now. What TR will do, TR will pass on this message to merchant that this token is not valid anymore, you please delete at your end. If you are not deleting it, then it cannot be used again because that token is not valid anymore. So these all communication happens via API. So normally TSP provides API by which you can activate your card token, deactivate your token, delete your token, change your keys. So all those parameters, which are all these features which I was talking about, these comes under the token lifecycle APIs. So for that, TSP has created a lifecycle API. Those API has been implemented by TR and then merchant. And then whenever these happens, by using that API, you can do that. And as all the information is there at the merchant side, so it becomes very easy because the merchant is connected online, everyone. It becomes very easy to, you can say, run those API and do all these things. And also, TSP provides, yeah. It's a real time, sir. That's why I was talking, it's not a bulk processing, the file processing, where every time after 1 hour a file is getting generated and it is getting passed to the TSP. It's a real time. That's why
So this will get deactivated immediately.
Yeah. That's why it is API is there. The moment you do that, issuer will trigger that API to the TSP, and TSP will trigger it to TR, and then TR to the merchant. So how the merchant, TR, TSP, and issuer.
Like also, when we buy credit cards, we are told that you are insured for if the card gets lost or there's some fraud in the card, you are insured for 2 lakh rupees on it. So if before I go and deactivate on net banking, before that if there is some fraudulent transaction which has happened, is the user liable for that, or because you are from NPCI, so you'll be having a better view. Like, is the user liable for that, or is it the payment company, or
no? I think one is as a consumer, you can always raise a chargeback that these are the fraudulent transaction, and that liability comes under the issuer. So that is between a divided liability between the issuer and consumer. That networks and then merchant doesn't come into the picture when there's a liability for a card or for an account.
But when he has been told that you are insured for 2 lakh rupees of any...
So that is between your bank and you only. And also So also for this token lifecycle management, TSP provides a, you can say, UI to the issuer, where those issuer who doesn't want to implement the API on a real-time basis. So that UI, that's a portal, which is again connected to our system and then connected to the TR. So using the portal, issuer can deactivate or activate the token and do the token lifecycle management. So these are the two methods. Normally, TSP provides it to the issuer. One is using the API. We always prefers to implement it using the API. And the second one is using the portal. So those issuer who doesn't want to implement the API, or there's a challenge to do that, so till the time period, the portal can work. And this service works in all scenario. Let's say your card has got expired. So in that also, that by using the portal, the creation of the request of the creating new token can be given. So this is a flow for the card on file tokenization. So how it happens normally? So as a consumer, let's say this is the first time you are logging into any of the merchant app or merchant website. This applies to both browser and the merchant app. You are logging into the merchant app and you are entering your card number. So after entering your card number, there are two options. One, as a consumer, you don't want to do a payment transaction, you just want to register your card. Or second, you are doing a payment transaction and there that merchant shows that option to you that do you want to save your card detail or not. If you tick that option, means you have given a consent to the merchant that yes, you are allowing that merchant to store your card number. So how it happens? The moment you have ticked that, first your payment transaction will get completed. After the payment transaction, provisioning will happen. Provisioning means registration of the card. Provisioning is related with when you are registering a card on any of the app or merchant site and you are generating a token. So provisioning will happen. How that will happen? That merchant will send a request to the TR and TR will send a request to the TSP that these are the card detail. I want to register this card. Please generate a token. What that TSP will do, TSP will generate all the token credential, PAR, reference number, expiry, keys and everything and give back to the TR. And TR will pass on the reference number to the merchant. If the PG and the TR is different, let's say I'm a merchant, my transaction goes with a payu, but my token generation method, I have a, you can say, agreement with the Razorpay, who is acting as a TR on behalf of my merchant. But that Razorpay is not routing my payment transaction. Then there will be two entities involved in the transaction. One who will fetch the token or generate the token from the TSP, and another who will pass on the normal transaction to me. So during a card registration and payment, first what happens? First the payment transaction gets completed, then the tokenization provisioning request takes place. Because why? Because we don't want to, you can say, disturb the consumer behavior. If we start registering the token first, and during that if the transaction get failed, then as a consumer you will feel, oh, card to chalta nahi hai. So your payment transaction first should get completed, then this token generation and registration will happen. If that got failed, you will get a method card cannot get saved.
Excuse me? Sorry, the topic. So I'm asking questions. This card tokenization which you told and save the card is same thing?
Yeah.
Save your card for future reference.
Save your card. Previously, you were just storing the card number on the merchant side. Now, there's a technology behind it that whenever you are saving your card number, the merchant cannot store the real card number. So for that, the merchant need to go to the TR and TSP to get a token and store the token number at their end.
What are the chances of, if I click on save my card for future reference, what are the chances of fraud? These fraudsters will get this, they will get this past OTP
No, because how this merchant is connected to TR, that's a dedicated network. And then again the TR is connected with the TSP with a dedicated network, one. Second, when we are getting a request from a TR for generating a token, we are validating the TR also. So there is a, you can say, first the handshake happens between the TR and the TSP, whether it's a genuine TR or not. So there is some, you can say, technical mechanism in place where we identify the TR first. So there's no way any fraudster can come in between, because the connection between the TR and NPCI and as a TSP is dedicated, one. And then there is a server and SSL certificate, all those handshaking happens. So that there's a, I will not say it's impossible, but there is no chances because that's a dedicated network.
And this two-factor authentication and all this stuff which has come right now.
Yeah. So
tokenization and all. This is earlier implemented in foreign countries. We are just copying it now.
No. I think none of the country has mandated this card on file tokenization. In US, you will not find this regulation is there. I think here, RBI has come up with this idea to mandate this particular, you can say, tokenization at all the merchant side.
So cash checkout tokenization is not required,
Guest checkout is something where you don't want to store your card number. You just want to process a transaction using your card number, and then so if you do that, then every time when you are logging into that merchant side, you need to enter your entire card number. And this is a token-based transaction. So how the transaction happens? First, the merchant has a token reference number, and now the moment you hit the button, pay with using my this save card. So what will happen? The token reference number and associated detail which merchant has, merchant will pass on this request to the token requester, and then token requester will pass on this request to the TSP. I have got a token fetch message from a merchant for initiating a payment transaction. Please provide me the credential. Now you can say that TR has the token number. Why he is going to the TSP again? Yes, because we want to be very sure that the merchant who is having a token reference number is not having the token PAN. Because if I will not do this, then I will never ever be sure that whether the merchant has having the real token PAN or he is having only the token reference. Then creating this entire reference par that will never help. So that's why at the time when the TR is fetching the token from me using an API, what I do, I create a cryptogram. That's a cryptogram which I was talking about. I create a cryptogram and I pass it out to the TR. And I say, please pass on this number, unique number to the merchant, so that whenever merchant will send me the transaction, the payment transaction, I will validate. It is something like you have come to me and say, please give my flat key to you. And now, along with that flat key, and you are giving the key to your friend. So along with the flat key, I have given you a code also. And I have asked you, give that code to your friend. And whenever he will come to my flat, I will re-verify the code. Once it get re-verified, then only I will allow, else I will not. So this is something how the fetching a cryptogram from the TSP helps for a payment transaction. So now that, this is 5 minutes I think. So now, as the merchant has got that cryptogram and then token reference detail, now he can initiate the payment transaction using all those credentials. And he can send the transaction via the PG which is linked with that. So here, two entity comes into the picture who is connected with the merchant, one PG and another TR. It can happen the PG and TR can be same. That's it, I think, from my end.
So I have two questions.
Yeah.
First is, now the payment gateways are not allowed to store even the card in encrypted format, right? So how the use case of offers will work? So earlier how it used to happen is, whenever customer has transacted, PG used to store that card number in an encrypted format. And whenever he is coming again, the card PAN was again verified and that offer was applied. So how in such scenarios
you have at the merchant end, you have the token reference number and the PAR. You can use the token reference for flashing out all those offers which you want to run. Now the pain comes that it can happen that one card has got registered many times. So
I'm talking about the scenario where the consent is not given.
you just describe me the offer which you want to talk about.
In a payment gateway, there might be offer that if a customer is transacting twice, we'll give him some offer, right? So in that case, card won't be stored, the consent won't be taken from the customer because customer is not opted for saved card. So how such cases work?
So in that case, against that card, there is a reference number which is there at your end. And using that reference number, you can track. You need to store that reference number. Whenever the customer is doing a transaction, after a successful transaction, let's say there's a flag, you mark that the one-time customer has done a payment transaction using this reference number against this particular PAR. Again, if a customer again want to initiate a transaction, again the same reference number will be used until unless the token doesn't get changed. Okay? So there also you got an info that the same ref number has got used twice. So now you can run the offer.
And
so here you treat your reference number as your PAN number.
Okay, and And one more question, are PG allowed to store first 6 and last 4 digit for
I think as per RBI only first 4.
Okay.
So the question that he asked, right? If I want to share, say, I want to give offers, but that party is not accepting the token from PCI. In that case, how will it work?
No,
How can I share my?
So just clarify a little bit more. What do you mean with that party
So
is not
I
accepting?
stored my card number on the merchant website,
Huh.
right? And I did a payment transaction. It went fine. Now I want to use my same card number, pass it on to another third party.
Another third party means another consumer, huh?
Another, it may be any other software providers,
Hmm.
right? So can I share my token with somebody who has?
No, no. Rule one. As a merchant, you don't have a token also. You have a token reference number 1. Now, it is not allowed to share token reference from merchant 1 to merchant 2. That's a standard hygiene. If you are doing that, then to get a real token during a transaction, that merchant need to connect with the TR. Whether TR will allow you? I don't think that any TR will allow you. So I think you got the answer. No?
Okay, so in an ecosystem there where there's multiple merchants, not.
So one thing is that all the merchant who want to manage this tokenized transaction and to store the token reference number, they need to come via TR. And the TR is connected with the TSP who is generating a token and giving to the TR. We are trusting a TR. We are not because we as a scheme we don't manage merchant. We manage the player who is requesting a token on behalf of any of the merchants. So I am trusting the TR. Now it's a TR job to make a trust between the merchant and get a token credential for processing any token-based payment transaction.
For the merchant website, is it required to encrypt the token reference?
No, token reference number is an encrypted one. Na. You don't need to do anything on that. You have a token reference number, you can keep it as it is at your site.
And on a token, we can set an expiry. Can we also set an amount limit? That is maximum amount.
There is a facility, but because as a TSP, if I will start doing that, then it will be very tedious job for me to maintain the limit against each merchant, each consumer. So that's why no one does that.
Yeah, hi, Nishant. So you just discussed about the tokenization. So there are various way of creating the token. One is carbon file, the other one is on HC, and then secure element. The logic and the specification for all the tokenization is the same for all the modes, or
I think whether you are doing it a SCE, token on device, or you are doing a card on file, ultimately the token lifecycle management is managed by the TSP. So and TSP has a vault. So whatever the functionality which you are enabling or disabling using this vault, the logic of storing the token will never get changed. The only difference will be on token on device when you are generating the token. So that entity who is requesting the token, like let's say you are doing it on a Google Pay, then there Google Pay itself is a merchant and he is acting like a TR also. He is directly connected with the TSP and he is getting a token credential for storing it on the device. But the method of managing the token, why the TSP will change the method from a use case 1 to use case 2? That doesn't, I don't think, but there's no point of doing that.
yeah. So my question is basically on the standards and the specification. So, right? Why we have to build two systems for device as well as on COE?
No, there is not two specification. These are the two methods to store a token on the device. If you are having on a mobile phone, you are having a Myntra app or Flipkart app, and you are also having a Google Pay app. In Google Pay, you are storing the token and you are using the Google Pay as a tap and pay, mobile tap and pay. And in the Flipkart, you are storing your token as a card on file. So both these methods is connected with the TSP. How below this token, what all the, you can say, payment application which is there, which used to perform a token on device tap and pay transaction, that is there at the GPay. So I know whenever the Google Pay will come say, hey, please register my card. So I know this Google Pay is a TR, is now requesting for a token on device. So along with the token, all those parameters which I talked about, I will also provide him the card credential, like a EMV parameters, EMV keys, all those certificates and all those things. Because I know that he is asking for a token on device, not a token on file. Now let's say Google Pay says, I also want to be a token on file or a card on file. So there he need to register with us as a different TR. So Google Pay is registered with me as a 2 TR. 1 as a token on device, 2 as a card on file. But all are connected with my same system. My system should be common. And that when I'm creating the system to manage the token life cycle, there is a standard guideline, EMV core and all. If you want to do that, you can do that. If you want to be a domestic player and you want to create your own standard, that still you can do that.
So only registration I have to do twice, otherwise the logic and everything.
Correct.
All right, thank you. With this, we end.